Alright, welcome once again to Mathematics Meal. We are still on theory of logarithm, and so far we have looked at the meaning and the laws of logarithm. Today we want to look at simplification of terms and expressions involving what? Logarithm. So this episode we lay the final foundation that we need before we can now begin to solve problems on logarithm. So stay away from all forms of distraction. This is the third objective. We have 2 more to go, but this third objective is lengthy, so we'll still break it down to different episodes. So let's begin without wasting time. Let's look at simplification of terms and expressions involving what? Involving logarithm. Now, it is important that we understand what we mean by terms or expressions involving logarithm. So we say this: any term or expression that contains log operator, any term or expression that contains log operator is a logarithm term or expression. So how do we know that a term is a logarithm term or logarithm expression? There must be log operator in that term or expression. For example, let's say examples now. Examples, you can have log 27 base 9. This is a log term. It's a logarithm term because it contains a log operator. If I have log 32 base 4 minus log 8 base 4. This is also a log what? A log expression now, because you have more than one term. You remember in algebra we say that when we have collection of terms, when we have more than one term, we are going to have expression. So this logarithm expression, then we can also have log maybe 8 over log 16 etc. This also another expression, an expression involving logarithm. So once there is a log operator present in that term or expression, it means that that term or expression is actually a logarithm term or logarithm expression. Now there are 3 cases that we are going to look at. There are 3 cases. There are 3 cases. There are 3 cases of terms and expressions involving logarithm. 3 cases. 3 cases. So we look at them like this. Case 1. Case 1. When we have only one log operator. Example, we have log 1000 base 0.1. Okay, let me just use 10. When we have just one log operator, like we have here, just one log operator, we can just, if more, have log 65 in base 25. So we now say etc. Just one log operator, that's a case. Then we have case 2. Case 2. What's the second case in the simplification of what? Of terms and expressions involving logarithm. The second case is a case when we have many log operators. Many log operators. There are so many operators here now. Example, let's say I talked about the examples here, can have log 250 base 5 minus log 2 base 5. We have two log operators here. Can have log 9 base 3 minus log 8 base 4. Two log operator here again. Can also have log 100 base 4 plus log of 5 base 4. So, two log operator. You can extend to 3 log operator. That's why we say many log operator. Many log operator. So let's just put one more that will contain 3. Let's say I have log 16 base 10 plus log 50 base 10 minus log let's say 8 of base 10. We have this. So in this case now we have so many log operators and so on. Then the third case that we are going to look at is when we have division of logarithm. When we have division of logarithm. So these three cases are the cases we are going to consider in simplification of terms and expressions involving logarithm. Now, why is it important that we break them down into these three different cases? You know, this simplification, there are so many variety of terms, variety of expressions that involve what? Logarithm. So we need to break them down this way. The method used in simplifying an expression or a term that contains one log operator, it's not the same thing you use here, it's not the same thing you use here. That's why we need to break them down in this way. So we'll consider this separately, we'll consider this separately, and we'll consider this separately. There may be cases where you have combination of these cases. So by the time you have gotten the knowledge of each of them separately, so even when they are combined, you will know what to do, because you now have the knowledge of when you have single log operator, just one log operator, when you have many, and when you have division of logarithm. So examples here. We have, let's say I have log with 27 over log 9. This division, I have log 0.04 over log 125. This also division, and so on. And so on. Okay. So this is the end of the foundation that we need to lay. So in our next video now, someone will say, we have not solved problem. Don't mind me. We are not solving any problem yet. The problem begins from this in case 1. And that's what we are going to handle in our next video. We are going to see how we can solve problems involving just single log word operator, how we can handle it. Make sure you have watched all the videos on theory of logarithm so far. If you don't know the meaning of logarithm and you don't know the laws of logarithm and you cannot understand these categories or these cases of simplification of terms and expressions in logarithm, you will have problem. I mean it, you will have problem in mathematics. So we are trying to solve your problem, so take it easy. It is a meal, and there is no way you just, if you overfeed yourself, you have a problem. Very much a great problem. So that's why it's a meal. We are giving it to you like food, so that you just take a bit and it will digest. After digesting, then you can eat another one. Well, if you continue to eat and eat and eat and eat without digestion, then you will start vomiting. yes, you may not end in vomiting anyway, you may still start defecating. So as it's coming out, as the mathematics you have learned is coming out from your mouth, it's also living through your anus at the same time. But we don't want that, and that's why we are giving it to you as what? As a meal. Okay, we shall be back in our next video, and that video will now treat the first case in simplification of terms and expressions involving logarithm. And in that episode, we'll solve some problems in the simplification of terms and expression involving logarithm using this first case. Till I come your way next time, make sure that you continue to enjoy mathematics meal. You can also ask your friends to subscribe to our YouTube channel, and then just go to Facebook, look for Mathematics Meal 1. It's going to go a long way in helping us in the publicity of this video. Thank you, and God bless you.